All right, welcome back for another deep dive. Today, we're tackling something that I think is pretty crucial, especially if you're aiming for those senior software engineer roles. We're going to be talking about design patterns.
Yeah, design pattern. They're not just some abstract concept you read about in textbooks. They're like the building blocks of good software architecture.
Exactly. And during those technical interviews, being able to demonstrate that you understand these patterns, it really shows that you're not just coding, you're thinking about the bigger picture.
Absolutely. It shows you can design systems that are flexible, maintainable, and scalable.
Well,
All the good stuff, right?
right. And today, we're going to really zoom in on one specific pattern that comes up a lot, both in development and in those interviews.
A pattern that can really level up your understanding of how to structure your code.
It's the command pattern.
The command pattern.
And at its core, it's all about encapsulating an action as an object.
Now, that might sound kind of vague at first.
Right. Like, what does that even mean?
So let's think about a real-world example. Imagine you're at a diner, okay? You're the customer, you're hungry, you want some food.
I'm always hungry.
Who isn't? So you tell the waitress what you want, right? Let's say a burger and fries.
Classic.
Now, does the waitress go back into the kitchen and start cooking your burger herself?
No way.
She writes your order down on an order slip. That slip goes to the cook, and the cook is the one who actually makes the magic happen.
Right. And that order slip, that's kind of the heart of this whole thing.
It is. Think about it. The order slip represents your request, the specific food items you want, but it also implicitly says, hey, cook, this needs to be made.
And the waitress doesn't need to know how to grill the burger or anything like that, right?
Nope. She just knows that order slip, once it's in the cook's hands, things will get done.
So how does this relate to software?
Well, that order slip is our command object.
Uh-huh.
It encapsulates the action, like make this burger, and it identifies the receiver, the cook, who knows how to do it.
So the waitress is kind of like,
The invoker. She triggers the execution, but she's totally separate from the actual cooking process.
and that separation, is that kind of the key point here?
It's huge. That decoupling, that's what makes the command pattern so powerful.
Okay, so back to the software world. Formally, the command pattern, it's about taking a request and encapsulating it as an object.
Right. And once you have that object, you can do so much with it.
Yeah, like what?
Well, for starters, you can parameterize clients with different requests,
Meaning,
meaning you can have different parts of your system asking for different things using the same basic mechanism.
oh, okay.
You can also queue up requests. So imagine you have a bunch of tasks that need to be done, but not necessarily right away. You can wrap each task as a command and put them in a queue.
Interesting.
And another cool thing is you can keep a log of requests. This is really useful for things like auditing or debugging. You can see exactly what actions were performed and when.
Oh, that makes sense.
And perhaps one of the most common use cases is supporting undoable operations.
Like in a text editor.
Exactly. Ctrl plus Z, that's the command pattern in action.
Cool. And all this is possible because we've taken those actions and turned them into objects.
Right. And objects, we can pass them around, store them, manipulate them, you name it. It gives us so much flexibility.
I'm starting to see the power here.
Now, remember that decoupling we talked about?
With the waitress and the cook.
Yeah, in software terms, that means the invoker, the thing triggering the action, doesn't need to know anything about the receiver, the thing actually doing the work,
So they're totally independent.
which is amazing for building complex systems. Imagine you're working on a microservices architecture.
Where you have all these independent services talking to each other.
Exactly. The command pattern can be a lifesaver there. It lets services communicate without being tightly coupled.
So they can evolve independently without breaking each other.
That's the goal. And it makes deployment and maintenance a whole lot smoother.
Okay, so we've got the big picture. Let's break down the actual structure of this pattern.
Sure. We have a few key players here. First up, the command itself.
This is the abstract idea of a command, right?
Right. It's usually an interface or an abstract class that defines what a command should look like.
So what does it actually look like?
Well, the most common method you'll see is execute. That's the method that actually carries out the action.
Makes sense.
And if you want to support undo functionality, you might also have an undo method.
So that's how we handle that Ctrl plus Z magic.
Exactly.
All right, so we have the abstract command. What's next?
Then we have the concrete command.
This is where the rubber meets the road, right?
You got it. The concrete command takes that abstract idea and gives it a specific implementation.
So it's like, okay, we know what a command is in general, but what exactly does this command do?
Exactly. And the concrete command, it knows which receiver object is going to actually perform the action.
Ah, so it's the link between the command and the thing that does the work.
Precisely. And its execute method will call the right method on the receiver to get the job done.
So give me an example.
Sure. Think about a paste command.
Like in a text editor.
It would hold a reference to a document object, the receiver in this case. And when its execute method is called, it just tells that document, hey, paste whatever's in the clipboard.
Okay, that's pretty straightforward.
Or take an open command. It might have an application object as its receiver.
And what would its execute method do?
Well, it might have to do a few things. Maybe prompt the user for a file name, create a new document object, add it to the application, and then finally open it.
So it can be a multi-step process.
It can be.
Mm.
And these concrete commands might need to store some data related to the operation too.
Like the file name in the open command example.
Exactly.
Okay, so we've got the command, the concrete command. Now let's talk about the receiver.
The receiver, that's the workhorse. It's the one actually doing the heavy lifting.
And it can be any class, right?
Pretty much. In our examples, we had document and application.
But it could be anything that has some action we want to perform.
Right. It could be a light object with methods to turn it on and off.
Or a stereo with methods to play music, adjust the volume, things like that.
Exactly. Or a ceiling fan with different speed settings. Or even a garage door that you can open and close. The point is, any class that has methods representing actions, it can be a receiver.
And the concrete command is what bridges the gap between the command itself and the receiver.
Right. It directs the action.
Okay, next up, we have the invoker.
The invoker, that's the one that kicks things off. It's the one that says, go.
But it doesn't actually know what's going to happen, right?
Right. It's totally oblivious to the specific command or the receiver.
All it knows is that it has a command object, and that object has an execute method.
And it just calls that method. It doesn't care what happens next.
What are some examples of invokers?
Well, think about a menu item in a graphical user interface.
When you click it, something happens.
Yeah, that menu item is the invoker. It invokes the command that's associated with it.
Or like a button on a remote control.
Perfect example. The button itself doesn't know what it's controlling. It just knows to send the signal.
And lastly, we have the client.
The client, that's the one that sets everything up.
It creates the concrete commands and connects them to the right receivers.
Right. So, for example, in a desktop application, the main application class might be the client.
It would create those menu items and link them to the appropriate commands.
Like a save command linked to the currently active document.
Or in our remote control example,
You might have a remote loader class that acts as the client.
it would create all those commands for controlling different devices.
Like the lighten command and the light off command. And it would configure the remote control by assigning those commands to the right buttons.
Okay, let's talk about that remote control example in a bit more detail. It's such a classic way to illustrate this pattern.
It really is. So imagine you're building a universal remote, one that can control everything in your house.
Lights, TV, music, maybe even the garage door.
The possibilities are endless. So our remote control class, that's our invoker, it has slots for all those different buttons.
And each slot can hold a command to turn something on and a command to turn it off.
Right. So it might have a method called set command that lets you assign specific concrete command objects to those slots.
So for button number 1, I might assign a lighten command and a light off command.
And both of those commands would be linked to the same light, say the living room light.
Okay, so now I press the on button for slot 1. What happens?
Well, the remote control has a method, let's call it on button was pushed. It takes the button number as an argument, in this case 1.
And then,
Inside that method, it doesn't have any code that knows specifically how to turn on a light. It just calls the execute method of the command that's assigned to slot 1.
which is our lighten command.
Exactly. And that command knows to call the on method on the living room light object.
So the remote control itself is totally generic. It just delegates to the command.
That's the beauty of it. And the
Yeah.
same thing happens when you press the off button,
It calls the execute method of the light off command.
which then calls the off method on the light.
So if I want to add a new device, like my stereo,
All you need to do is create the right concrete commands.
like stereo on command and stereo off command,
Link those commands to your stereo object, and then assign them to a new button slot on the remote.
and the remote control itself doesn't need to change at all.
Nope. It's already set up to handle any command that follows the command interface.
That's really powerful.
It makes this system incredibly flexible and easy to extend.
And who takes care of all this setup?
That's our remote loader class, a client.
It creates all the different concrete commands, connects them to the right devices, and then configures the remote control.
It's like the mastermind behind the scenes.
Oh, and one more thing I wanted to touch on, that no command object.
Ah, yes. That's a handy little trick.
So what if a button on the remote isn't assigned to anything yet?
Instead of having some special case handling, or worse, a potential null pointer exception,
We just assign it a no command object.
which is basically a command that does nothing.
It's like a placeholder.
Exactly. And it keeps things clean and consistent.
Okay, let's shift gears a bit and talk about undo functionality.
Ah, the magic of Ctrl+Z.
Remember that undo method we talked about in the command interface?
That's where the magic happens.
So each concrete command, it needs to know how to not only do its action, but also how to undo it.
Right. So for our lighten command, the undo method would just call the off method on the light.
And the light off command would do the opposite.
Exactly.
And how would we implement this in our remote control?
Well, we could create a slightly fancier version, maybe call it remote control with undo.
And this version would need to keep track of the last command that was executed.
We could have a variable for that, maybe call it last command.
And every time a button is pressed, we update that variable.
So we always know what the last action was.
And then we add a new button to the remote, the undo button.
When you press that button, it calls a method, maybe undo button was pushed.
And that method simply calls the undo method of the last command.
Boom. We've reversed the last action.
Now, things can get a bit trickier when you're dealing with commands that involve changing the state of an object.
Like our ceiling fan example.
Right. The fan has multiple speeds.
So when you execute a command to change the speed, you need to remember what the previous speed was.
So you can go back to it if you need to undo.
Exactly. So our concrete commands for the ceiling fan, like ceiling fan high command or ceiling fan medium command, they would not only set the new speed, but they'd also store the previous speed.
And the undo method would use that stored value to restore the fan to its previous state.
It's like taking a snapshot before you make the change.
This whole undo functionality, it's a really powerful aspect of the command pattern.
It is. It adds a whole new level of flexibility to your applications.
And it's not just about undo. The command pattern has other cool applications too.
Oh yeah, plenty.
Like what?
Well, imagine you have some tasks that take a while to complete. You don't want to block the main thread of your application while you're waiting.
Right, that would make the UI freeze up.
Exactly. So you can use the command pattern to encapsulate those long-running tasks.
Each task becomes a command object.
And then you can put those commands in a queue
A job queue.
and have separate worker threads that pick up those commands and execute them in the background.
So the main thread can keep running smoothly.
Exactly. This is a common pattern for handling asynchronous operations.
It's also great for managing systems that get hit with bursts of traffic. You can just queue up the requests and process them as you have capacity.
Right. And speaking of managing systems, the command pattern can also be really useful for logging and auditing.
How so?
Well, you can extend that command interface, add methods like store and load.
What would those methods do?
Store would serialize the command object, basically convert it into a format that can be saved.
And load would do the reverse.
Exactly. And then you can store these serialized commands in a log file or a database,
So you have a record of every action that was performed.
which is super valuable for debugging, auditing, and even recovering from crashes.
So if the system goes down, you can reload those logged commands and replay them.
And get the system back to its previous state.
That's pretty slick.
It's especially useful in systems where data integrity is crucial, like financial applications.
Okay, and one last application I wanted to touch on, macro commands.
Ah, yes, macros, a classic example of composing objects.
So because commands are objects, we can treat them like any other data. We can group them together, create collections.
And that's what a macro command is. It's a container that holds a bunch of other commands.
And when you execute the macro command,
It just executes all the commands inside it, one after another.
so it's like a sequence of actions all bundled into one.
Exactly. Think about a graphics editor. You might have a macro command for save and backup,
It would first save the document, then make a backup copy.
all with a single click,
Very convenient.
and very powerful.
So to bring this back to our listeners who are preparing for those senior software engineer interviews,
Knowing the command pattern is a big plus,
it shows you understand core design principles.
like decoupling and encapsulation. Those are fundamental to building good software.
And being able to explain the pattern clearly, maybe using an analogy like the diner or the remote control, it shows good communication skills.
Which are essential at a senior level.
Yeah.
You need to be able to explain complex ideas to others in a way they can understand.
And it's not just about knowing the theory. Being able to discuss practical applications is key.
Like how you would use the command pattern to implement undoable, handle asynchronous tasks, or do robust logging.
It shows you can think critically and apply these concepts to real-world problems.
Exactly. It demonstrates that you're not just a coder, you're a software engineer. You're thinking about the big picture.
So to sum it all up, the command pattern is about taking actions, wrapping them up as objects, and gaining a whole bunch of benefits from that.
Decoupling, flexibility, extensibility, undo functionality, the list goes on.
It's a pattern that shows you understand good design principles and can create systems that are robust and maintainable.
And for our listeners out there, here's a challenge for you.
Think about the systems you've worked on or the applications you use every day.
Can you spot any places where the command pattern might be in use, even if it's not explicitly called that?
How could applying this pattern improve those systems, make them more flexible, more resilient?
Ponder on that. It's a great way to solidify your understanding of the command pattern, and it might even give you some ideas for your next project.
Keep those brains churning, everyone. We'll see you on the next deep dive.
Happy coding.